So today we are going to be finishing up our stairs and landing at our new garage workshop. This is something we can do and stay out of the construction people's way to keep things moving along. To give you a quick review, in the first episode we did a kind of timber frame-ish design for the landing. In that the overall frame uses a lot of mortise and tenon joinery that is drawboard to keep it tight. We're using just leftover material that was a misorder, and we bought some 4x4s for stretcher parts on that. And then I found some various 2x4s that we use for the landing. Now these are the only parts that are use metal fasteners. We just nailed them down, and we nailed them down on 3 members coming across. That way, if any of those would warp one way or the other, by having that center node on there, it'll keep it somewhat flat. And we got it about 1/4 of an inch below the back landing right there, so if we put a out-swinging door, it'll be just fine. And this section right here is removable so that I can back my pickup truck right here. Now the stairs we're going to be doing, we're going to go the same route, kind of overcomplicating everything. So let me show you what I'm thinking about. I should be embarrassed because for the past 2 weeks since we finished this timber frame landing for the back of our new shop, I have not built the stairs yet. In fact, Dad found some, I guess they're RV plastic stairs on the roadside that he's been using. So, to make this a little bit safer, today we're going to build some stairs the worth the effort way. Now Dad was originally wanting a 12:5 step ratio, but at this particular height that would mean that we had to go 7 steps down to make that one. I convinced him to go 12:6 because I'll actually cut off one whole step. And I am planning on doing a timber frame design as best I can. It's going to be an original design. I haven't seen anybody else do it like that. I've gotten inspiration from everywhere else, so I'm just kind of winging it. And because I'm winging it, I think that probably the best thing to help me visualize it is to go ahead and make a template. So what I now have here is a rough idea of the layout of the stairs. It's actually 12 inches too high, thus I have 12 inches too much wood on the back. So that's the layout offset by 12 inches. And I did all that just so I could figure out this cut right here, because my goal is this template will be a center support, and it's going to fit right in here. And I couldn't visualize all the math to do it. So just laying it out 12 inches offset, I could then just take my rulers straight up and down and measure it. So hopefully I won't waste a $12 2x12 with this next cut. I did all that, measuring 12 inches up, all that kind of stuff, just so that I can take relative measurements off the exact same piece, because Frankly, I didn't know how to do that in CAD or whatever, stuff like that. But now that I have a template for not only the placement, but the length and all that kind of stuff, I can now start doing side rails, other kinds of joinery, and that simple piece right there will be a center structure just to tie it all together. It won't be totally wasted, but even if it was, it's 15 bucks to help me lay something out in a very weird setup where uneven terrain, all that kind of stuff. So from here on out, I get to use my furniture making skills that I've depended upon for years. Just figuring out a way to transfer past knowledge is all I'm doing. A lot of work to do that one. But from here on out, it'll be easy on me and I won't have to stress about it. Now I know what I'm about to do and what I've been doing leading up to this point is going to seem kind of janky to a lot of y'all, but it really is the difference between those of us that build off of blueprints, where everything has to be on the blueprint so we can fit all our joinery before the assembly, and those of us that design off of a napkin, bar napkin. Get a rough sketch, get the overall dimensions, and then we fit parts to it. This whole idea of getting that metal stretcher right there, while it won't really be part of the timber frame design, it allows me to position the steps somewhat where I want them to be. And the whole purpose for that was to capture angles in the wild, because I didn't know what the undulations of the ground are going to be, all these slopes and stuff like that. So if I can get that angle right there coming down to the ground, well then everything else can be based upon that, because I know my steps are going to be 12 by 6 inches, so all my joinery cuts can be based off of that. I just need to be sure I got that angle, and how I did it is really simple. I laid those steps out, I got them somewhat level, and then I'm just going to go drag the stretcher to where I want it to be. So with that, I've now captured the all-important angle right here. That's going to affect how my tenon goes in here. And I've captured the top of the step. Everything else I can base off of measurements, as long as I now have these two measurements and their reference on this piece right here. So what we now have are two tenons. They've got to angle them so they can actually slide in. So that right there is going to be fitting on the top line that we drew on our board. And this is going to slide in and come down a little bit. So we actually need to start our tenon approximately 1 inch higher than the line we drew on our board. Or maybe to make more sense, we want to end up on that line right there. So to get that line and have that dovetail, we actually want to slide it in, and it's going to drop down into that dovetail. Meaning I've got to start the mortise this distance higher than that line. What the? Dad! What? Okay, people, remember, don't let others borrow your tools. So, me being the highly precise guy that I am, well, you just saw me actually get the exact measurement of the step on the board by just tracing it out, placing it where I want it to be, getting it level, and drawing myself 2 lines, and actually just 1 line, the top of it. And then I came down 1.5 inches from that, based on the ruler height, And from there, I cut myself a shim, and I just mark 6 inches down to get all the subsequent steps, because it is a rise over run of 12 by 6, so it should be okay. And I'm taking a very precise measurement of 1/3 of the way through for the dadodes that I'm going to be cutting. That doesn't have to be perfect, just as long as it's consistent. So if I just set this thing up once, I make all cuts for both sides, I should be fine. Well, it's looking like everything's lining up, which is good. I was kind of worried about that. So now I need to visually kind of line everything up where I want it to be. So now I take this top measurement up here, simply because this is the closest distance to the joint that won't move. And if I get this dead on perfect and extend it all the way down, at least I know it will be parallel. I did that because I've always found that when you have the arm rail start over here, this end post, well, there's nothing really preventing it from rocking this way and that way. You can stop it rocking this way and that way because it's connected right there, and that's a very strong structure. But there's no preventing the racking motion. But by having it maybe halfway back, well, I have a connection point here, but I can also connect the bottom on either side. That will create that triangle, and it will prevent some of this racking. Plus, I've always found that when you're going up on stairs, you generally take a step and then reach up. You don't need it way back here. So this will prevent, I think it'll make the armrest a little bit more solid. And now to do this one, I'm going to try yet another joint, because I would kind of like to make it even with this outside, and that protrudes a little bit. So I'm going to do a more than halfway lap joint on this side and a partial lap joint right there. So the first step is to mark that out. So coming down from the position right there to maybe the third step, that is actually 30, let's say 40 inches. Now make that same mark on both sides. Now here is something that I was kind of perplexed about when I was putting these lower stairs on. And I just noticed it, and it really brought out when I just did that measurement. Because all my stairs are parallel. Bubbles in the center. But when I draw my 40 inches, it's in the middle of this stair and it's down there a little bit. And I have the feeling it's because these two rails are on different planes. Notice they're also coming out different levels. But because I took that initial measurement and drew them right on the board, I was never really concerned with the exact angle of all these cuts, because I just had to make them parallel all the way down, and it's working out just fine. It's getting me nice level steps, but the measurements are a little bit different for each side. And boy, do I know that it's going to be driving a lot of y'all that work to blueprints crazy. But if all the contact points are working just fine, there you go. To get these posts perfectly, I came down that 40 inches, or just the same number on both sides. I'm simply going to put a clamp down there, get my spirit levels just right, and then make my half lap marks. Just make sure you keep the flat of your pencil on the wood so you're not making it smaller than it needs to be. There we go. Now all I have to do is set a depth I'm coming in on this board and a depth I'm coming in on that board, and I'll be okay. On second thought, I'm just going to do a lap on this one. I think it'll be more than strong enough with a torsional, especially if it connected up top. And I'm just going to set that depth so it's flush with this cutout right there. That way, anywhere that this step, it'll be up against this one. It'll look kind of cool. So now that all that's left is to add in the rails. And the standard height for most rails, according to my references, is 36 inches. And because everything about this is not designed to blueprint, I'm taking measurements directly off the piece. All I've really got to do is get the uprights parallel, mark 36 inches from the top of that bottom rail up, same over there. And then I have my measurements, lengths, angles, and everything like that. I do believe because of the offset, I'll probably do a lap joint on the end and a mortise and tenon on the structural rail. So there we go. I didn't really bother showing you cutting out all the mortise and stuff like that. Just a little quick montage, just because I covered how I did that in the last video where we built the landing. This time, it was just a lot easier because we already know how to do everything. So the next step in this is gluing it all up. Cleaning off down. Dad is cutting out some dowels so that we can peg those. And I will probably glue and nail everything else. So, come along as we do that one, then we'll wrap it all up. Now, I have no intention of taking this entire thing apart to glue it up because there's very few things that actually need to be glued together. This is one of them, because if you remember way back in the beginning, this was a dovetail. It slid in and dropped down in the dovetail. So all I need to do is squeeze this together and that'll force it down. So really the only thing I need to glue in is this tiny little wedge I just cut out. So now that we've got the frame kind of anchored so it ain't ever going to move again, go ahead and glue up the arm rails. Now I am using Titebond 3 here, an outdoor glue, so hopefully it'll last longer than this, but like everywhere else, the glue is just kind of redundant. I talked about this whenever we built the landing for these stairs. It's the joinery that's going to hold it together. So these holes are actually offset. So what I want you to do is watch it kind of sink itself up as I bring it through. So we'll drop this in, get it as close as we can. There we go. And then I've got some dowels where the tip is kind of offset. So it's going to find those holes, which are actually drilled closer this way, so it's going to drag it through. So as I anchor it down, watch it sink up on its own. See how that kind of weaved it over this way? It's actually working its way around that hole. And if you listen, you can hear it change in frequency. Now bottomed out. Next, I'll focus on these posts, I guess you call them. And how strong is that draw boring? Well, don't need clamps to hold it up anymore. Stays the same angle. It's all because you sunk it down hard to the shoulder. Remember, mortise and tenon joinery, whether it's in a box, a table, or even some kind of structure, it's a shoulder where you gain your strength. So I'm going to apply glue to this and that. We'll clamp it together, and then I'm going to peg these, not draw bore them. Now I did say I was going to do these differently in that I'm going to peg it, which means There's no offset. We're just going to drill a hole and drive pegs through. All this takes is a little bit of glue because, well, all the glue is doing is keeping the peg in so it won't back out. And I also did not have to taper the end. Saves you one small step. I'll do the same thing to the top, and then I'm going to let it sit overnight for the simple reason I'm losing light. And tomorrow we'll come back in, I'll throw a clamp on the bottom of the stairs, and we will nail the rest of it together. So there you go. A timber frame-ish design of a staircase and landing. We did the landing this last episode, and I just kind of wrapped up just nailing some loose ends together here. Nailing literally. Yeah, most of it was joinery where I was having fun, simple joinery. you know, dados and not even putting shoulders on the tenons that slid in them, just slapping it all together. Mortise tenon joints with some dovetails just so that it will slide down, and then a locking pin so that they will never come out. Really wasn't that much glue on this one, just mainly on the pins that were going together, but we end up with something where not all the measurements are perfect. I got a little bit weird thing on the landings, but no big deal. They are level, they are even, they are sturdy, and I haven't even braced the bottom of these posts right now yet. The last thing to do is just grab some 180 sandpaper on a random orbit sander and go over everything, you know, breaking edges, using my eraser to get rid of the pencil marks, and Dad was going to throw some paint on it. Yes, this was a lot more complex than just going and buying 3 stringers, using some Simpson ties and anchoring it there and just having at it, but it was fun. It's going to be a kind of a conversation piece when people come by, because even the construction people that have been in the shop, they've been coming over and looking at, what is he doing? Probably saying, why is he doing that way? This guy's nuts, putting way too much effort into it. But they're talking about it, and people have been jumping up and down this even before I put the pegs and glue on it. So it's a rock solid design. A design I did on the back of a napkin. And because of that, I didn't really have any real measurements or angles. But I reached my goal. And I hope a lot of y'all would, you know, try stuff, risk stuff, design it the same way, and just go out and build it. Don't overthink it. Now, I apologize for the length of this video. I got kind of rushed. We are in the last stages of building our new shop. That's what this is for. So in the future, you know, come back and you'll see lots of tool installations, dust collection installations. We'll be doing interior cabinetry, that kind of stuff, to make a shop for me and my dad to cohabitate without killing each other. One thing I've got to do is make sure I keep my tools to myself. Well, y'all be safe and have fun, and remember, it's always worth the effort to learn, create, share with others.